Hi everyone, we are Group 2 and I'm Bobby.
My name's Nick.
I'm Jacob.
My name is Max.
I'm Cole.
Alright, and we got our data from US Energy Information Administration. The data range from January 1st, 1973 and to December 1st, 2017. And the GEM software aided us to creating relevant models such as the time series analysis, the logistic regression model, test of means, and the multiple regression model. And we have analyzed the relationships between the electricity net generation from nuclear production with other variables. And beside that, we have created new variables such as the decade because we don't have monthly data until 1990s. So we have created decade 1 from 1970, decade 2 for 1980, and so on. And so, next.
Alrighty, the first thing we did was a test of means, and we did it to test our first hypothesis. Our null hypothesis is there is no significant relationship between nuclear share of electricity net generation in decade, and our alternative hypothesis is there is a significant relationship between nuclear share of electricity net generation in decade. Looking at this figure on the slide, we can see by our Levine's test that the variances are significantly different. Due to that, that means we cannot use ANOVA and must use Kruskal-Wallis to see if there is a significant difference. Based on this figure, we can see that the Kruskal-Wallis test gives us a p-value of less than 0.0001, which is lower than our desired confidence interval of 0.05. Using that value, we are able to reject the null hypothesis and conclude that there is a significant relationship between nuclear share of electricity net generation and decade.
Alright, so before we talk about time series model, we will first explore the trend of variables such as nuclear electricity net generation, capacity factors, and nuclear share over the times and decades. So, by looking at the graph, we found an increasing trend between nuclear electricity net generation and month. However, it started growing gradually in decade 5. There's an interesting fact we found that the mean difference between decade 4 and 5 is only 955 million kilowatt hours, which is approximately 12 times smaller than the mean difference between decade 3 and 4, which is 11,650 million kilowatt hours. Next, we take a look at the nuclear share of electricity net generation. By looking at the graph, we also found a trend with a rapid increase of nuclear share from decade 1 to decade 3 with 9.21% and 19.41% respectively. And the trend maintaining a mean of around 19.50% for the last 3 decades. Last but not least, we take a look at the capacity factors. So this factor being used at the beginning of 2008, and it calculated as the monthly nuclear electricity net generation divided by the maximum possible nuclear electricity for that month. The graph shows us that it increased from 56.89% in decade 1 to 90% in decade 5, which indicates a very significant improvement on the generation technology.
Right, for us to predict which forecasting model is the best fit for the data, we have run it through time series analysis and several smoothing models, and we found that seasonal exponential smoothing model is the best fit as it has the lowest AIC, MAP, and MAE, and we also found that simple exponential smoothing is the worst smoothing models to predict the next month period of generation as it has the highest AIC, MAP, and MAE. And to predict the next month's nuclear electricity net generation, we saved the seasonal exponential smoothing model as it is the best model to predict the next month generation. So we saved it, and so from the graph we can see that the next electricity net generation for next month will be 6,000 66,816 kilowatt.
Alright, so then we began to look at the relationships of our various variables, predictors, and when there's a desired outcome. So we wanted to look at the nuclear electricity net generation. In our initial model, with every variable included, which was the capacity factor, net generation, summer capacity, month, and total operable units, we had an adjusted R-squared value of 0.9715, which is fairly good. But when you ran a VIF column variable, they were extremely high, which shows that they're super correlated. So our next regression model, which was our final model, showed that capacity factor and summer capacity were our best predictors for our categorical response. That had an adjusted R-square value of 0.9886, which is extremely high and much better than the initial model that we initially had. And then we looked at some adverse effects, some variables that held a negative estimate. And you can see decade 1 and decade 2 both had negative values. So, as well as nuclear share of electricity net generation.
Next, we decided to use multiple regression models to prove our hypotheses with the data. Our first hypothesis was there's a significant relationship between the nuclear share of electricity net generation and decade. Based on the multiple regression data alone, we failed to reject the null hypothesis, and this is because when we initially created a multiple regression model using nuclear share of electricity net generation as the response variable and our created categorical variable decade as the predictor, we found an R-square value of 0.775 and a p-value of less than 0.0001. And we think that this data shows that there's a positive relationship between these two variables, aka as the decades went on, there's a greater share of electricity net generation from nuclear power. But based on this multiple regression data alone, there's not enough evidence to show a significant relationship between the two variables.
All right, as far as external evidence supporting our findings, we talked about earlier how the 1970s was fairly low, and then the 1980s nuclear net share of nuclear energy as a share of net energy started off low in the 70s, rose a little bit in the 80s, and the 90s and late 90s, early 2000s, it kind of peaked, and then it seemed to plateau a little bit off after that. The low start in the 1970s can partly be attributed to the negative stigma around nuclear power caused by the Cold War. And again, going back to the adverse effects chart that you saw earlier, decade 1 and decade 2, which were the 70s and 80s, had an adverse effect on nuclear energy generation, and that would be right during the height of the Cold War. Around the late 1990s and early 2000s, nuclear energy became a greater presence in net energy generation because of new and more efficient generators that were created around that time. And also around that time, the effects of climate change were becoming more prominent in the media and just the world in general. And so people were exploring a lot of different avenues for renewable energy to help reduce the use of fossil fuels. Looking towards the future, nuclear energy generation is expected to decline because of generators being taken offline and the fact that there are not as many new generators being produced that are being taken offline.
In conclusion, we enjoyed working as a group doing this semester project. We learned a lot, but also we not only learned about how we were going to use the data to prove our hypotheses, but we learned how to work as a team to get through this semester project. Our first hypothesis that we created with this data was that there's a significant relationship between nuclear share of electricity net generation and decade. So, based on the test of means, the time series, and the multiple regression data, we reject the null hypothesis. This means that we were able to prove a significant relationship between our nuclear share of electricity net generation and decade. So moving on to the next hypothesis, our hypothesis 2 states that capacity factor and summer capacity factor are predictors of nuclear electricity net generation. And based on our logistic regression data, we reject the null hypothesis. So what this means in layman's terms is that if you wanted to predict the nuclear electricity net generation of a reactor, you would be able to look at the capacity factor and the summer capacity factor and be able to figure out how much nuclear electricity net generation there is. Those are our two hypotheses, and this is the finalized ending of our semester project.
We're group 2, by the way.
We're group 2.